Hello, friends. Yeah, it's been a minute, but we are finally back with another episode. In this case, episode 206 of the Our Weekly Highlights podcast. We have been off for a bit, but this is the show where we talk about the excellent highlights that have been shared, as well as some additional things as time permits in this week's Our Weekly issue. My name is Eric Nance, and hopefully you didn't forget my voice. I feel like it's been a bit since we last were able to speak to you all and your favorite podcast players. I've had definitely a whirlwind of a few weeks, and I just would say a note to future self. Agreeing to do 3 conferences in a matter of 2 weeks may not be the best for your your stability, but I got through it, and the last one was especially fun. But nonetheless, I am here, but I am not alone. Thankfully, who's able to carve up a bit of time today after a bit of chaos is my awesome co-host, Mike Thomas. Mike, how are you doing today?
Doing pretty well, Eric. Apologies to the listeners. Will probably sound a little bit different today. I'm using, unfortunately, my earbud headphones to record instead of my typical microphone, which has officially bit the radish. And I think this is one of the byproducts of having not recorded for a couple of weeks, is I decided to test out my microphone about 5 minutes before we jumped on and realized that it is officially out of commission. So I will be hitting up Amazon very shortly and should sound better next week.
No, we know how it goes, and just like with infrastructure we've been spinning up, sometimes when it fails at the most inopportune times, and we gotta put those things out. Luckily for you, it's an Amazon click away. Some other times it's a lot of blood, sweat, and tears, so to speak, with getting everything back set up. I've been down that road too, especially in my Docker adventures, literally right before we record here, but I think I got it solved. Anybody that runs Docker on Windows, we're going to talk about this a little bit, you definitely have my sympathies. Man, WSL is a thing to deal with. Anyway, I digress. I tend to do that from time to time. So let's look at the notes here. It has been a minute, Mike. We always do our prep show notes together. Let's look at the curator here. Well, of course it would be. Whenever I have so many things going on, usually that's the time when I have to curate an issue. But thank goodness I was able to get one out there. And we got a lot of great selections to talk about. So this was a pretty easy one for me to get out to the door. But as always, I could never do it alone. Had tremendous help from our fellow RWiki team members and contributors like all of you. With, in this case, I think it was a whopping 5 or 6 pull requests that had some great resources that have been shared in this week's issue. So without further ado, let's get right into it. I already teased it out, right? There is a novel technology that's, hit the software development landscape for the last almost like 15 years, it seems like, and that is the world of container technology. The way that you can encapsulate not just a quote-unquote application or a library, but its own system dependencies and what you might say is a cross between a full-blown virtual machine on your system and a more fit-for-purpose architecture. In this space, the Docker runtime for containers has been what usually gets the most attention. It's had the most mind share, you might say, but it's not the only game in town, of course. There are some other ones like Podman, which has a lot of compatibility with Docker. And if you want to get really low level on Linux, you can use what's called LXC for those kind of containers. As an R user, you may be wondering, what are some of the best use cases for this? And I still stand by what I'm about to say, is that in the context of Shiny development, containers are a massive help. It opens up a lot of doors, a lot of possibilities for how you can scale this, to use those cliches, and also more transparently, actually where you host it. There are a lot of options available to you. You may be new to Docker and you're wondering, oh gosh, I have to be a Linux expert to get this started as an R user. Not necessarily. You can grow into it because our first highlight is talking about a fantastic package to kind of ease your way into the world of Docker, especially in the context of Shiny development. And it comes to us as the package called Shiny to Docker with the number 2 in the middle. And we have a great blog post from the team at ThinkR, in particular Vincent Guider, who I believe is a co-author of this package, to introduce Shiny to Docker and give us the use case of just why it's important and the mechanics of how it works. The team at ThinkR has been using Docker for quite a bit. I've had multiple conversations with the esteemed Colin Fay also a fellow curator on the R Weekly team on his container adventures, and of course WebAssembly adventures on top of that. But Docker has been a key focus in one of Mike and I's favorite packages, Golem, to help with those deployment concerns. And I'm gonna say it again because I can't resist. Once you go Golem, you never go back, at least in my humble opinion. I'm getting virtual applause from Mike here, so I'm not too off base here. So they've always had hooks to use Docker to help generate a Docker file for probably the past year or so. But now they've encapsulated that functionality into a standalone package, hence Shiny to Docker. So what does it give for you on the tin, so to speak? You get to have what's called the Docker file, which in essence is the instructions that you give the Docker runtime to build your, what you might call image or application-based image. Shiny to Docker is going to help automate that process to create it for you. It's also going to interact nicely with renv or renv, where out of the box, it's actually, if you don't have one already, it's going to generate an renv lock file and detect what versions of packages you are using on that application library and bootstrap that for you to ensure that reproducibility of the package version. I do have additional thoughts of that towards the end. I'll save it then. But what's also nice is that Shiny to Docker, in the role of the CI/CD, especially with GitHub Actions, GitLab runners, and whatnot, it's going to help you create either a GitLab CI configuration or a GitHub Actions workflow YAML file, which is wonderful to not only build a container on that infrastructure, but also to push it to a registry of sorts for these container images, the most prevalent one being the Docker Hub as one of those. But you could also choose additional repositories as well. And that is a huge deal because then with that image in place, you can then choose where you deploy that. So how do you get started? Well, of course, you're going to install the package with the typical install.packages because it is on CRAN as you record. So you can get it straight from CRAN or RUniverse or other places like that. And then the rest of the blog post gives us kind of a case study for preparing a relatively simple Shiny application where it's in a simple app.r, very much the hello world type geyser, faithful, I should say, histogram that we all know very well. And then once you have that encapsulated, it's time to generate the Docker file. It's simply a call to Shiny to Docker, give it the path to where your app.r is, or rest of your Shiny files, and then it kind of takes care of the rest in a very use this like fashion. Going to give you the Docker file ready to go, a special text file called .dockerignore, which if you're familiar with version control with Git, you can have a .gitignore to tell Git, don't touch that file. Environment variable files say hello. Don't ask me how I know. But you can have the same thing with Docker ignore. There may be some things that your application has that just were more for development. You don't really want that in your Docker image because you do want to keep the size a reasonable image size because that's going to, potentially elong your download times when you actually call this to run. And then throughout the step, it's got a lot of nice kind of error, checking. Like I said, it's bootstrapping renv out of the box for you to help with getting that lock file. And then it's going to give in that Docker file the command to actually run the application using the Shiny run app function, which we typically put, like I said, at the end of these Docker files, these instructions. And then once you have that in place, then you can step back to Docker itself, run assuming you have Docker on your system, which again is a prerequisite. I do want to say, in my humble opinion, working with Docker is much easier on Linux than some of the other operating systems, whether Mac or Windows, but I feel especially sympathy to the Windows users because you do need the Windows subsystem for Linux, version 2 of that in particular, to run Docker on your system. Trust me when I say that can be finicky depending on your corporate environment. So best of luck with that. Mike might have something to say about that.
To say Casper can help. We've done that a lot, but yes, you're exactly right. Once you get WSL2 installed, I would just highly recommend installing Docker Desktop to automatically install the Docker engine and give you a nice UI into all of your running containers and images as well.
Right on. That's exactly what we are recommending. Some of you may be aware it's a side tangent, but I am part of the submissions working group under DR Consortium. Literally, as I record tomorrow, I am set to transfer the next version of that pilot with the Docker version of a Shiny app. And yes, you better believe in my instructions for the reviewers, we have install WSL and then install Docker Desktop. We need the easiest way for them to get containers running. So yes, that is a very on-the-point recommendation. So once you have that in place, you're going to build the image with Docker build. You can give it what's called a tag, like a little label for that. And it's going to inspect that Docker file and then let the magic run, so to speak. Build it layer by layer. And then once you have that image in place, then you can use that at any point on your system with the Docker run command. Give it a port that you want your Shiny app to be exposed on. Give it a name if you wish, the name of that image afterwards. And then you're going to get a process in the terminal to say, okay, your app is running on localhost or port whatever. Then you can browse to that port. Typically, you can map that to port 80 if you want to make it super simple, but you can choose any port really at that point. And then you've got yourself a Shiny app. It should work just as if you were running this in your R environment, like in RStudio or Positron or whatnot. It should look just like that. That's the whole idea. It's just another way to execute your application, but your application source code is the same. So the post concludes with some nice kind of practical tips to give you the most smooth process to get yourself in this container journey. One, as you're iterating, I'm sure you're going to have like cruft in your app directory as you're typing stuff. Once you're done, like you've got a stable thing, try to keep that relatively clean. And when necessary, add things or add directory names or file names to the Docker. Ignore if they're really not meant to be used by the container. They do recommend, and I actually wholeheartedly agree in this context, RM from the start, just outside of this Docker file or Shiny to Docker pipeline, can be helpful. Although I just gave a talk at our medicine about how I think Nix honestly can be an even more attractive alternative to this. Mike someday will be converted to that. We're not there yet. But I have proven in multiple projects now, Nix can also fit nicely with Docker as well, where you can have the Nix help with your development libraries for the app and even at the system for that matter. And Docker, instead of using R and RM to bootstrap that, you can just bootstrap that same Nix recipe, if you will. You'll get that same version of packages. Myself and Bruno Rodriguez, between our talks at our medicine, hopefully the recordings will be out soon. We think in Shiny there's a pathway there. So I digress. Other great things to think about. Definitely look at things locally before you rely on CI/CD to help with a lot of this. Trust me when I say where things can happen in your CI/CD scripts, or if it's the YAML instructions that you give it, or like me, or glutton for punishment and put some bash shell scripts to automate creation of files. You may just mistype one path and it just all goes haywire. Try to test that locally first. You'll thank yourself later. Also, you want to make sure that you're thinking about security in mind. You don't want to put a lot of sensitive credentials in these images just in case. Hopefully there's ways around that in the future via environment variables. In the platform you choose to deploy this to, many of them support that, where you don't have to put it in the code, so to speak. And yes, this is your gateway to Docker, but it does help to have a little bit of background into what's happening in like that Docker file, set of images, how do you get system dependencies inside, where does R fit in the picture. It does take a bit of getting used to. I won't pretend I have everything figured out, but knowing the way the layer system works, you want to put the things that are most frequent to change towards the end, not towards the beginning, because once you change something, everything below that step will have to be recompiled anyway. So if you think about it, if your app is really iterating, you want to put references about the app code as far down that Docker file as possible, which again, Shiny to Docker is going to help you with that step, and then keep the package installation stuff towards the top. That way, if that's pretty stable, you just iterate on the code. It'll be much less time to compile these Docker images than if you had the app stuff at the beginning and then you're like doing all the package installation. Yes, that can be, it's like watching paint dry sometimes. So you just got to be prepared for that. In the end, very nice, gateway as a Shiny developer to get into containers. In my humble opinion, I think this can also work nicely with Nix. Maybe I'll talk with the authors of this in the future about having an extension of sorts with that, with Rix. Who knows? The ideas are out there. But Mike, you and I are big fans of containers. What did you think about Vincent's post here?
Yeah, we try to containerize everything, especially Shiny apps. I really like this post and the introduction into the Shiny to Docker package that seems to utilize heavily the Docker filer package under the hood, which I had been previously familiar with because that's a dependency of Golem. Golem
Yes.
has some functions, I believe, in the dev folder, the O3 deploy script for those Golem developers out there that allow you to create a Docker file for some of the different sort of end places where you might be landing your Shiny apps. And it's a one-liner that does a lot of this type of thing behind the scenes. And it looks like Shiny to Docker kind of extends this a little bit. Some of the packages I think that really help in this process, one of my favorites is the attachment package. And I know Shiny to Docker leverages that. And there's this function from attachment called create rn for prod that Shiny to Docker uses under the hood, which can actually, I believe, sort of ensure that all necessary R packages for your app are accounted for in the Docker image via your rn.lock file. And one thing that I will mention is getting, rn and Docker and everything to play nicely can be a little tricky, especially when it comes to sort of updating your app and updating packages in your app. But once you get the hang of it, and I think thanks to some of these other helper functions, it can be a huge lifesaver, especially around dependency management and making sure that what works on your machine works in production. And I will definitely echo your statement, Eric, about making sure that you test these things as you create a Docker image and run a container first before you just throw it at your CI/CD process. Um, we've seen a lot of folks who will do that and they'll test things, but then they'll make like one more final little change to their app before they create the pull request that kicks off the CI/CD process, and they don't retest because they really don't think that's going to actually affect uh, anything else. But of course, it does, and the CI/CD breaks, and everybody has to have a meeting and a conversation around how are we going to fix this. And if you before you push things out to that CI/CD process, if you promise yourself to test it first, which means that you're going to run a Docker run command locally, you will cut down on many of those meetings that I have sat in before to hand off sort of the app locally to production and the DevOps team that's going to actually stand that up. So that's my word of wisdom here. I know, Eric, that you are a big fan of Nix as a potential replacement for RN. I probably shouldn't even say this, but we build a lot of Shiny apps that don't even leverage RN, but use the R2U image from Dirk Edelbutel, which just grabs the latest version of all of the R packages that your app depends on. Obviously, the trade-off there is full reproducibility. If you only have a couple dependencies, and if you're actively maintaining that app on a day-to-day basis, then I think it's okay to make the argument to leverage that approach. It's just sort of a choice on our end, but if full reproducibility is really important to you, then leveraging our end can definitely be the way to go. One of the interesting things that I found is that Shiny to Docker creates this Docker file that typically uses a base Docker image called Rocker Geospatial. So it's the geospatial image from the Rocker project, which comes with R, Shiny, and I have to imagine a lot of geospatial libraries as well. So I believe that you could sort of customize this after the fact, right? Because we're just creating this Docker filer object that we can then edit. So it might be a good idea to look into that and determine if that image is the base image for you, especially if you have some constraints around size of Docker images that you're allowed to have and that your DevOps team is sort of expecting you to hand over the wall to them. I know that this geospatial image from the Rocker project is already over 1.5 gigs by itself. We tend to create a lot of apps that are actually just around 1 gig. Again, we like to use that R2U image pretty often, which keeps things quite small. So if you do have performance limitations like that, it just might be a consideration, but in a lot of circumstances, that might work perfectly for you as well. I think one of the interesting things that you may not know is tools like Posit Connect and ShinyApps.io. They are doing this behind the scenes, their own
Yes.
version of this. So
Yep.
when you submit your code to either one of those services, they're going to build a Docker container and they're going to use some sort of workflow that they have. I don't know if it uses Docker Filer, if it uses Shiny 2 Docker, but they're going to try to essentially parse your code, scan it, and take a look at all the dependencies that you have and what's going to be needed from an R package dependency standpoint, a system package dependency standpoint, a version of R, and I imagine operating system standpoint as well. And they're going to try to do their best job of putting that Docker file together and doing this for you. So I think this is sort of the next step to try to take this in your own hands. I think it can be a really helpful introduction to Docker for those who are not necessarily familiar with it. And as you continue to use this workflow, maybe you'll start to also get comfortable with taking a look at the Docker file that gets generated, seeing if there's optimizations or enhancements that you can potentially make to fit what you're trying to do a little bit better than what is trying to be automated behind the scenes. But this is a great gateway project, as you mentioned, and really excited to see it.
Yeah, there, when you think about building it locally, sometimes you're not as concerned about these other issues you identify, like the size or the base image you're basing off of. Sometimes you just want all the things right away, make your development easier. But yeah, once you narrow down the hosting platform you're going to throw this on, totally agree. The more you can run this locally and iron out any issues before you throw it over there, the better off your life is, whether CI/CD or, like I said, just deploying to these cloud-based platforms. Because if you can narrow down, let's say something happens on the hosting platform and you're convinced that your app works, you can show your IT support that, guess what, running this on Docker locally, whether on my own machine or what I had to do recently. Some may know that GitHub has the product called Code Spaces, where you can boot up what it in essence is a containerized environment for VS Code. I would install my Docker image on there, pull it down, run the app, and make sure it works there. And that's obviously not the biggest, resource footprint that it has available. So you verify that it works in these other situations. And if your hosting platform's still not working, then you've got some stuff to tell IT. It's like, I did my homework. It's working on these things. This literally came from personal experiences. We're experimenting with Kubernetes stuff at the moment. And I was driving myself batty because it was working fine in these other instances, but not there. But now we've got some things we can troubleshoot. So that's more in the trenches situation here. I think the big picture is the container technology, great for a lot of reproducibility. It also just gives you a lot of options for where you put this that you don't necessarily have if you just keep the app as is. We didn't even mention there's another platform that you work with a lot, Mike, called Shiny Proxy, that also is very heavily based in the container footprint as well. You bring the app as an image there, Docker image or container image, if you will. They have different options even in that orchestration engine. So there's a lot out there. You give yourself a lot of possibilities. I've actually talked to the Posit folks about, well, Posit Connect Cloud is great. If you could give me like a way I can bring my own container, we're golden, but we're not there yet.
Yep, no, you're exactly right. Shiny Proxy is another option where it is a bring your own container option. You have to, it's open source, so you have to set the environment up yourself and manage it all yourself. But if you prefer to go that route, then that is a great possibility in the many choices that we have for Shiny deployment these days.
Well, geez, we just got finished talking about container technology for sharing your Shiny apps, but especially been following this show along with recent developments, you know there's another challenger, as they say, for how we distribute Shiny apps in a very novel way, and that is, of course, with WebAssembly. In particular, the terrific work authored by George Stagg with WebR, and now with the Shiny Live package, where we can take a Shiny app that has minimal dependencies and throw that into a WebAssembly process, and then our individual browsers become that engine, much like how Docker was the engine to run the Shiny app in our first highlight. Why am I transitioning to WebAssembly now? Well, because our next highlight here is indeed a Shiny app in the context of exploring what is actually under the hood of a ggplot2 visualization, but it has been deployed as a WebAssembly app. This has been authored by Jun Cho, who has been a very prolific developer in the visualization space with ggplot2. And apparently this idea has been in the works for a while, because he's actually talked about the idea of understanding how the different layers in a ggplot come into play as you're constructing these visualizations. He's written papers on this. He's actually given talks such as at the JSM conference, as well as our Studio Conf before that, about his take on the layering approach, and a package that he has co-authored in the ggplot2 ecosystem called ggtrace, which is another novel contribution here to basically look at the internals of ggplot2. And in fact, one could say that this ggplot2 Layer Explorer app that we're looking at literally right now as we speak is an intelligent GUI front end to the ggtrace functionality. So right off the bat, like of any WebAssembly app, you put the URL in say Microsoft Edge, Google Chrome. Firefox can be hit or miss in WebAssembly, just saying that, but at least for this one, it seems to work fine. Once it loads up, you've got yourself a pretty typical, looks like a scatter plot with a linear regression line best fit. It's a predefined plot as option one, but you got multiple options here, such as a bar chart, looks like a density curve. I'm just clicking through here, a box and whisker plot, as well as a violin type plot split horizontally. In each case, you can look at the plotting code in the little code editor at the top, and you can make tweaks as you see fit. Like if you have your own favorite plot, you can just throw it in here if you like and regenerate the code, because WebAssembly, again, has that R console kind of baked in. You can just run this code at your leisure and try stuff out. And once you have your plot, you've got really interesting ways of selecting the different components of these layers on the left side of the app with this little radio group button here choice of, say, the compute position, the geom type of data inside of that. And on the right side, you've got now a way to inspect what is actually in that layer in that particular call to the ggplot2 functionality, such as like in the case of this violin plot, I can look at what's happening with the geom violin code here, look at the data behind the scenes, look at both the input and the output as well in a nice little data table. And if I want to run some of these expressions that ggtrace is exposing, I can run that on the fly and refresh the data set or the summary based on the code I put into that yet another editor. This is fascinating. You can even get information of the layer at a higher level with a modal that pops up of the different classes, the subclasses, and the methods that are composing that layer. This really is, I use the cliche, looking under the hood. This is as close to like really getting into the internals of a car engine, but in ggplot2 speak, as I've ever seen. And the fact is, I can do this all interactively. This is amazing. I can only imagine the amount of work that has gone into building this. But like good documentation practices that Mike and I espouse many times to our projects, there is a very comprehensive about page in this app where you look at a high level how to use the app, what's the general workflow, and how you can do some common operations in here, like being able to compare the inputs and the outputs, try to run custom expressions to kind of massage that data a bit, and as well as exploring the graphical type of object output for each of these different geomes that you can run here. And there's a little button called hijack plot, and literally run what it would look like if you draw this onto the existing visualization. This is amazing. He does mention there are some, very fine scope that is exploring here with respect to ggproto methods. Again, I don't know nearly as much as what June knows under the hood of ggplot2, but I do feel like this is something I could bring my own plot to and really go to town with just seeing what are the building blocks of putting this together. A very technical deep dive into the magic that ggplot2 gives all of us. So very straightforward, streamlined app. I can see myself spending a lot of time with this in my next visualization adventures. But Mike, what are your first impressions of this?
Well, one of my impressions this week, I think, is ggplot, I believe, turned 18 years old. Did it have a birthday this week?
Yeah, I kept seeing that, or even 21. Like, I don't even know which one's correct now.
I don't know. I think it was 18 from everything that I saw, which would take us back to 2007, which I think sounds about right. Did you ever base plot before ggplot, or before you realized what ggplot2 was?
Oh, yeah. I was a heavy user of base plot, and then once I knew ggplot2, it's like my life changed forever.
Can you believe we base plotted?
Well, one of us on the call, I'm sure people are not surprised about.
No. I did the same thing when we were starting out with R. I think it was because I had a professor that didn't know that R packages existed and anything outside of base R, which from my conversations with others in early academia around that time, it's not unique, unfortunately.
Yeah.
But yeah, this is really, really interesting. The WebAssembly stuff still blows me away. Every once in a while, we'll be trying to do something sort of obscure from a plotting standpoint with ggplot2, where we have to go into a particular layer or a ggplot object and try to make a modification, right, to get it to show us this customized thing that we want. And I imagine that some of the wizards out there that do things like Tidy Tuesday, or is there a competition specifically around data viz as well, or did there used to be one on the R side?
Oh, there used to be one. Yeah, that's a good point. I forgot what that was called, but yeah, I've definitely seen it.
Pretty incredible, ggplot based visualizations. I imagine that they would occasionally do the same thing, and it's always felt to me like a little bit of the Wild West, like you're going into uncharted territory when you start really diving into a ggplot object and then looking at these particular layer attributes. But this web application that's been developed really makes it much more tangible and obvious for us to be able to take a look at those internals on a layer by layer basis. And I think it's a really interesting approach that they took to doing so. It's really helpful. I was playing around with the little R code editor to update the plot that they were showing us. I'm looking at predefined plot 3. And I'm making some changes to the labels and seeing how it sort of propagates down themselves. And I just find this really interesting. It's a great tool that's been developed for us to be able to do that. And it's a really good education into ggplot.
Yep. And while you were talking, I was doing a little sleuthing, and I have found the GitHub repository of this app. I put it in the show notes for all of you as well. There's some really handy tricks that he's doing from both the Shiny perspective and the WebAssembly perspective. So this is, I'm always on the lookout for where people can take the direction of WebAssembly, especially in the case of, you might call educational, really getting to know certain packages or certain analytical, methods. But in the case of visualization, oh my goodness, this is just an excellent use case. Because again, not only does it come with the predefined plots, the 5 choices, you can run your own and have it updated in real time. That, to me, the magic of WebR knows no boundaries, in my opinion. So I'm going to be definitely looking at this in more detail. Again, great example here. I hope George Stagg is aware of this. I'm sure he would be super thrilled to see where WebAssembly is being taken here. But yeah, credit to Juno and the rest of his contributors here for a massive accomplishment here. All right, for our last highlight today, we're going to shift gears a little bit, just getting a little more low level with R itself. And those of you who have been around R for a bit or maybe new to it, you may find that one of the critiques is, well, with R being an interpretive language, sometimes it's just a tad slower than obviously the lower level solutions based in, say, C++, Rust, whatever have you, especially lately. But there always have been, attempts to make R code faster, such as the aforementioned conversion to C++ via RCPP. That's always been a tried and true. And like I said, Rust is getting a lot more attention lately. But an unexpected repository appeared in the last week and a half. And this is on GitHub at the moment. This is a brand new effort. But a new R package that has been authored by Tomasz Kalinowski, who I believe is an engineer at Posit. He has authored the quickr package. And what does this really mean? Well, on the tin, it just says it helps make your R code run faster. How is this actually accomplishing it? Well, you have a function that exposes called quick, and then you feed into this the R code, i.e. a function that you've created that you want to make faster. And apparently with some of these examples in the README here, and again, kind of simpler arithmetic type of situations with double for loops, we are seeing some pretty substantial gains in the reductions in the time to run a quickr version of a function, going from a second to only 4 milliseconds. So I guess if you scale that up, that could be substantial gains there. What is it actually doing under the hood? From what I can tell in the README here, it is utilizing Fortran, folks. Yes, Fortran, a language you may not have heard about unless you were, like a real old timer like me in grad school, and we did have some Fortran happening in our statistics curriculum. It is apparently compiling this R function that you supply into the quick function into Fortran type of code. Well, that's an interesting creation, if I dare say so myself. So I'm intrigued. Now there are some caveats here that Tomas outlines here. This will not work with every type of function because it is dependent on the type of return value that you're going to use out of this. So there are some caveats to play. But I'm definitely intrigued, and apparently there is experimental support for using this in an R package. But yeah, some of these restrictions, I had to scroll to see this. You may have to make sure that your arguments are declared explicitly, their types and apparently their shapes as well. Not every type of input supported. It's just integer, double, logical, and complex. The return value must not be a list, along with some other caveats as well. So as I can see, this is early days, and that there is a subset of the current built-in R vocabulary that is supported. And he's got a printout of the 66 or so of those under the hood base kind of functions that are supported. But he does plan to expand this out in the future. So we'll keep an eye on this. There was a lot of enthusiasm on social media when I saw this shared out. But yeah, yet another contender to make your R code run faster with Fortran of all things. So hello again, Eric here. Unfortunately, during our recording, we had a snafu occur with our backend system and our connection for our awesome co-host Mike. So his take on this last highlight was unfortunately lost, but rest assured he was impressed with quickr as well. So anyway, we apologize. We won't have his audio, but let's go ahead and close out the show. So back to our regularly scheduled podcast.
This is gonna be the coolest party ever!
Yeah, this is one of those cases where I love to know kind of the genesis of building this. What is the big motivation here? Now, I am doing a little sleuthing on their GitHub repo. I do see a fellow contributor is the esteemed Charlie Gao, who is, of course, the author of Mirai. So my guess is there might be an async thing in play here. I don't know, but I may want to talk to Tomas sometime to see if he's around to get behind the code a little bit on this. But I'm intrigued, and knowing what Charlie's cooking up over at Pazza, there's a lot of things this could lead to. So fascinating discovery here, which again, you always learn something new on our wiki, right? This is definitely one of those. With that, that will wrap up our main segments here. I do have to get out of here because the day job calls again, but we definitely thank you so much for joining us. And once again, the R Weekly Project, it runs on your contributions. If you have a great highlight or a resource you want to share with us, we're a pull request away at rwiki.org. You can find the link in the top right corner. You have a custom, issue draft or pull request draft, I should say. Fill that out, and our curator of the week will get that in the upcoming issue, most likely. So with that, I usually talk about our social media handles, but I do have to skedaddle out of here. You can find that in the show notes. I write those show notes. A lot of work goes into that, so definitely check those out. And also, we have chapter markers, too. If you want to, skip to your favorite highlight, just hit that little skip button. If you're on the modern podcast player, it'll be right there for you. So with that, we'll close up shop here for episode 206. We're glad that we're able to record this to talk with you all again. And hopefully we'll be back with another edition of our weekly highlights next week.